Okay. Um, yeah. Hello, everyone. So today I just wanted to show off a cool little prototype I made for a rail game. What I mean by rail game is kind of like, when you have either in Donkey Kong Country when you get in the mining cart and you go along a rail, or if you play Sonic Adventure Battle, they have rail system that you can like grind on rails with your shoes and kind of go down things and stuff like that. It's used in quite a lot of games, but I recently just had a dream of like running around and jumping on rails and stuff like that, and I wanted to reproduce that. I kind of dreamed of a video game where it's all about rails. You run around in a rail world, and you just kind of go around and grind on everything. And so here, what I've done is I've built a little prototype in Godot. It's about 300 lines, and what you can see here is that so Godot has a really simple system for paths, which you can see. This is a path, and this is a path, and this is a path. These paths, they have shapes or meshes that are generated along the path, and you can customize them here. So you can see here, you can specify the shape, very kind of like primitive. But then what it does is it extrude along the path, which is great for what I'm trying to do here as a prototype. You can then texture it later, which is awesome. These paths are pretty cool because what you can do is you can click on the path, and then you can change the curve and that kind of thing. So I got basic logic in here for moving the character around, going along the path, and so I'll just show you the demo. So it's just using game controller, right stick to move the camera. Works pretty well. Then just jump with A. Jump doesn't feel that great, but it's easy to fix with some tweaking. And then you got some basic friction, moving around, jumping in the air, that kind of thing. So I got my player here. It's just a little pill. And then what I can do is if I jump into a rail, it will snap onto the rail, and he can then launch off. My little pill can launch off the rail, and he automatically gets launched off a rail when you end the rail, and then you can land on a platform, and then you can continue, and I can jump on the next rail. So very simple. You can see that draw distance there. But yeah, that's the basic rail system. I imagine this could be pretty fun, given that you create a whole level with lots of different rails and go around and collect various items and explore like the world. Yeah, I was thinking adding enemies, boosts, that kind of thing. I think it'd be cool to have different risk-reward system for speed on the rail, so you can fall off if you go like too fast or something like that. I was thinking about like a leaning system, but I was thinking maybe it's a little hard to detect when you're turning around corners and like how you're leaning and that kind of thing. So yeah, it requires some logic about checking out like what kind of turn you're going into and that kind of thing, which I don't know how to do yet. Maybe it might be as simpler than I think, but it seems like a pain. Might be somebody do some arcade physics where you just have a boost button, that kind of thing. You put enemies around and rings they can launch through and do tricks and stuff like that. So with that, I'm just going to show the code. Yeah, as I said, this is very short, very simple. And I used a few techniques here rather than using some built-in ones like the built-in collision detection for the rail. I opted to go for my own implementation, and then also with the paths, there's a caveat with using Godot paths, which you can't get the closest vector index. But yeah. So to start off things, I just have my player in the world, and then I just get the paths and I set which paths the player can jump on manually. I imagine this can be resolved by just detecting all objects in the scene that are either under an object or like yeah, so like maybe you have like a node that says all paths, and then under that you just do children and you pass that instead. Or you just detect by tag or something like that, or a property on each object in the scene. But yeah, so moving forward, I have a bunch of variables here for the state, rail speed, jumping, that kind of thing. I think I'll just go over the basic input and process. So here you can ignore the lines above, but I have a quit button. That one's simple. Yeah, just jump. I've only really have one button. It's just jump. If the action button for jump is pressed and the jumps are less than the max amount of jumps, then we just increment the jump. Set jumping true. If we are latched on, we want to jump off the rail, and then otherwise we want to reset the velocity y so that we can actually ignore gravity. Otherwise, if we release it, then we just set jumping false, and that's how our character can then proceed to fall. This process just updates the camera, nothing special. And our physics process, the overall physics process is basically like, hey, if we're on a rail, move along the rail and update our rail direction. The rail direction is used for the jumping. So when you jump off a rail, you need to know what direction you were currently traveling in, and project and set your character velocity go in that direction. If we weren't jumping and we weren't latched on, we want to see, hey, we're in the air. Well, I actually don't think this detects if you're in there. It just says like, hey, find the closest path and latch onto it. Otherwise, we're just going to do some basic character movement, which is like, if we're jumping, then add some velocity to go up. If we exceed the maximum velocity for jumping, then we're going to cut off at that time and stop jumping and prevent the character from going up any further. Otherwise, we're going to apply gravity. Then we just have some basic logic for figuring out moving the character in the direction. So you get the camera basis, where the camera is looking. Then you just get the input vector from the controller or the map, and you simply times those so you move in the direction that the camera is looking, or you get your direction and then you move. And the way that I calculate movement is I basically have a function for calculating the friction, and then I simply move after calculating that friction, and I move the character based on the world up direction, and if they're on the floor, then we just reset jumping. I do change the friction and the speed based on if they are in the air or not. So if they're on the floor, allow you to move around quicker, because if you're in the air, you don't really have anything to move, so it's just kind of like simulating like air diving, I guess, because there is wind friction, but the floor has much more friction, so then it'll stop you sooner. Calculate friction, very simple. If there's a multiplier for moving the direction, then we use that. If there isn't, we want to apply friction in the opposite direction, which is these two blocks here. So it just takes in the current value and then reduces it back to 0. Otherwise, it just stays at 0. Here's a jumping off logic. Here's where I said that you use the rail direction times the speed to get the velocity that you want to go. And then we kill the y velocity because, again, when you jump, you want to jump off something. You don't want to be at a negative velocity, because then your jump has no impact. It's like if you're at a negative velocity of negative 50, and you jump and you start applying jump, you have to go from negative 50 to 0, and then from 0 to your jump, and then your jump would just not really work or have any impact. It wouldn't look like your character's jumping at all. It just like pause and then go up. So we want to avoid that. So here's the find path and latch. I'm gonna get back to that later. First we'll cover the move along path. So the way that the rails in this prototype works is that it's you have the path from Godot. The path in Godot has a curve. That curve is simply calculated when you change the handles in the game. So you can change them at runtime, obviously, and then it has to recalculate. But in this prototype or in the game I envision, you would just set all the paths up and they would never change unless you really want to get creative and have rails that move along, which, hey, that could be cool. But then you have to get the array every time, and then you have to change the collision space and everything, and that could get pretty slow per frame. And I'll show you why in a second. But basically, since the rail is just an array of vector 3s, so x, y, z, you basically, when you're moving along the path, you have to say, what is the next point in the rail that I'm looking to go to? And you simply move towards that next point. So you ignore regular kinematic physics, which is like the gravity and stuff that I showed earlier, and you simply just say, I want to travel a certain amount of distance per frame, which is the speed rail times delta. And while I still have distance to travel, and the next point is less than the number of points in the rail, I'm going to get that next point in the rail, I'm going to get the distance to it, and then I'm going to travel that whole distance. And if there's distance left over to travel for the total distance that I need to travel, I'm going to increment the next point in the rail I need to go to and repeat. And once I've traveled the total distance, or I've ran out of points in the rail to go, I will exit. And you just continually update the position of the character based off that, because you move towards each point there. So it looks like he's moving along the rail, when in fact you're just saying, give me the next point in the rail and just move me slowly or incrementally to that next point. So it's just like this manual positioning strategy every frame that makes him look like he's moving smoothly. And this is like super basic. Instead of like using an input on a joystick of like which direction to go, you just look at the next point and move them towards that next point by a certain amount. And this while loop is compensating for the fact that in one frame you could travel n points in the rail, and basically what it does is it ensures that it travels the correct distance rather than jumping a distance over something, because that wouldn't be the same, right? You want to have a smooth curve. You don't want to have a jump through curves or anything like that. So that's the move along. The find path and latch works a bit differently. What I had to do was I had to create a dictionary, which is this self paths map. It's a dictionary of strings to arrays of paths, and the string is just the position in the world, which is x, comma, y, comma, z. So it's basically like wherever a path exists, wherever a point in that rail exists, I have to have that in this dictionary, so then I can check, like, given the player's current position, are there any rails that I can latch onto? So that allows me to reduce it to a very fast lookup, simple hash map or dictionary, same thing. And that way you're not like trying to find everything around you in a radius or using collision or anything like that. It's just like, hey, I know my position. Are there any rails in my position? If there are multiple, it gets the closest one, that kind of thing. So then it finds a segment, the nearest segment, to find in the path that it finds from that. If there isn't one, it returns false. If there is one, it converts to array, and we get the nearest segment, and based on the segment, we just latch on and we snap the character to the point. So it's going to be, the segment is going to have like A, B, and then your C, and so that always forms an acute triangle, and so you project your point onto the line, and then you snap your character to the line, so it looks like he's moving onto the line. Although I think this is kind of redundant. If you snap on, you're going to move towards that point anyways, so it might be smoother to not have this. And then you just set the current path so that the move along path works. So here's the setting all paths at the beginning. Here's the build path map. This is the dictionary that you have to build when the level loads. It's very simple. It just goes through and converts all the points to global points. Sorry, no, it doesn't do that. It just gets all the points, and then for each point, it has to register in the dictionary for that space in the world if the what path is there, and that way you can look it up really fast. There was one thing I have to implement my own get closest point instead of Godot's get closest point because it doesn't return the index. So that was a gotcha. It'd be nice if their library or their API just provided that. Then you just simply calculate which is the 2 points that are closest to you. If you don't have 2 points, you don't really have anything. Yeah. So it would just use the first one it found plus the next one or the previous one. And then otherwise it uses the distance. If whatever one's closest is kind of how it works. And then here's the snap point logic that I don't really need. But that's pretty much it. Yeah. I do use one of these things. Okay, interesting. But yeah, that's kind of it. It was very simple, very fun, less than 300 lines. But yeah, it's all for kind of my adventures in game development for now. It's a lot of fun. I might turn this into a game. I don't know. I think it'd be a lot of fun. If I tweak it enough, maybe add a fun character and stuff, it could be fun. But yeah. Anyways, peace out.